You will learn about Azure DNS Private Resolver, the Azure service that will enable you to resolve domain names from on-prem to Azure, from Azure to Azure, or from Azure to on-prem. How was the world before this service? So customers needed to deploy and maintain custom DNS servers on Azure virtual machines or on custom virtual machines and set up the forwarding rules for the DNS name resolution. This means that they need to maintain those virtual machines in terms of security, governance, and updates, and that was a customer pain point. So they needed a more simpler service to manage those domain names. And what could be better than a PaaS service to manage those domain names? For that, Microsoft Azure introduces the DNS Private Resolver to resolve this issue. With DNS Private Resolver, now you use it as a PaaS server within Azure to enable users to query Azure DNS private DNS zones from on-prem environment without deploying virtual machines-based DNS servers. So it will unlock the three scenarios from on-prem to Azure, Azure to Azure, and Azure to on-prem. The DNS Private Resolver will act as a custom forwarder, not as a DNS zone. It will forward the DNS query to the server that is authoritative for the domain name. When you work with Azure DNS Private Resolver, you will see that it has four construction sets, or four components. First of all, we would have the inbound endpoints and the outbound endpoints. Those are the dedicated subnets within the virtual network in which the DNS Private Resolver is injected to. Then you would have the DNS forwarding rule set that will define the rules for how to forward the DNS queries. And the fourth component is the virtual network links, which links the DNS Private Resolver rule to a specific virtual network to enable it to resolve the domain names exposed by the DNS Private Resolver. Let's deep dive into each one of these components, starting with the inbound endpoints. An inbound endpoint will use the dedicated subnet with at least /28 CIDR range and a recommended /24 for the production, and it will expose a private IP address that will be used for forwarding the DNS queries. An inbound endpoint resolves all the DNS zones that are linked to the virtual network where it is deployed. Typically, an inbound endpoint will be used to resolve the DNS zones from on-prem to Azure. And as you see from this private IP address, that will be used by the custom forwarder from on-prem environment. Next, we have the outbound endpoints, which will enable conditional forwarding name resolution from Azure to on-prem or from Azure to other cloud providers or to external DNS servers. It will use a dedicated subnet with at least /28 CIDR range and recommended /24 for production systems. So the traffic that will go to the external DNS server will leave through the outbound endpoint. Thus the name outbound endpoint for the egress traffic. Then we have the forwarding rule sets within the DNS Private Resolver. What is the idea of forwarding rule set? Well, if you want to resolve domain name like hub.azure, then you should go to the IP address of the DNS server that is authoritative for that domain name, which is in this case 10.004 with the port number 53. So forwarding rule set is a group of DNS forwarding rules. You can create up to 1000, and it's linked to one or more virtual networks, enabling them to resolve those domain names. That link to the virtual network is the one shown in this slide, which is the fourth component of the DNS Private Resolver. A rule set could be linked to multiple virtual networks. In terms of pricing, the Azure DNS Private Resolver does not depend on the DNS Private Resolver instance itself, but it will depend on the constructions or the components of the private DNS resolver, which are here the private resolver inbound endpoint and the outbound endpoint, and also the resolver rules. The inbound and outbound endpoints will cost each $180 per month, and for the rule set it will cost for $2.5. This means that if you create a DNS private resolver with one endpoint, one outpoint, and one rule set, it will cost you about $362. Here I have provided a sample to estimate the cost of this service. the cost or the pricing in Azure actually depends on the Azure region, and the pricing might also evolve and change over time. So make sure to always check the pricing details page for each service. When you work with Azure DNS Private Resolver, keep in mind those important notes. First of all, a private DNS resolver cannot resolve private DNS zones that are not linked to the virtual network in which it's deployed, because it will not have any way to reach those private DNS zones. So that DNS zone should be always linked to the virtual network where you have the DNS Private Resolver if you want to resolve it. Another important note is that a DNS resolver can only reference a virtual network in the same region, and a virtual network can't share or can't be shared between multiple DNS resolvers. A virtual network can only be referenced by a single DNS resolver. The Azure DNS Private Resolver unlocks the three scenarios for connectivity between on-prem to Azure, Azure to Azure, and from Azure to on-prem. This architecture here combines all the three use cases within one single architecture, but we'll go through each one of these use cases to understand better how it works. And we'll start first with the on-prem to Azure connectivity. So let's say here you have an on-prem environment that is connected over ExpressRoute or Azure VPN gateway to your hub network. And then you have in the hub a private DNS zone like contoso.azure that is linked to the hub. So from your virtual machine on the on-prem, you want to be able to issue a DNS query and resolve the domain names held by contoso.azure. So to enable that scenario, you will need to have a DNS private resolver with an inbound subnet that exposes the inbound endpoint that is 10.0.0.4, and then from the on-prem environment, you will need to configure a DNS conditional forwarder to forward the DNS query to the private IP address, which is 10.0.0.4 on the inbound subnet. Note that with this configuration, we don't need an outbound endpoint or a rule set. This is valid because you need here only to do the domain name resolution from on-prem to Azure. However, now in the second scenario, if you want to do the domain name resolution from Azure to on-prem, then you will need the outbound subnet. So for this scenario, here we would have a virtual machine that is deployed into a spoke network or within the hub also. And it wants to be able to resolve a domain name that is hosted on-prem, something like contoso.internal, for example. And on-prem, you have your own custom DNS server that is exposed over the IP address 172.16.0.10. So to be able to reach this custom domain name to resolve the domain name contoso.internal, you will go to configure the DNS private resolver forwarding rule set to say here if you want to resolve contoso.internal, then you need to forward the DNS traffic to the IP address of the custom DNS. And here, because we have the connectivity from the Azure Virtual Network and the on-prem through an ExpressRoute or a VPN gateway, then that virtual machine will be able to go through that route and then go to resolve the domain name from contoso.internal. So note that here the peering is not required. The peering here is used only to connect the spoke to the hub. However, for the domain name or for the DNS resolution, we rely rather on the rule set link, which will provide the connectivity to the DNS private resolver. And now let's check the third use case, where here we want to use DNS private resolver to resolve domain names from Azure to Azure. So here I don't have an on-prem environment, but still the architecture and the components are almost the same. So from a virtual machine that is hosted in a spoke network that wants to resolve contoso.azure, which is under the private DNS zone that is linked on the hub, it will be able to do that through the DNS private resolver forwarding rule set. So here the forwarding rule set will say if you want to resolve contoso.azure, then you will need to forward the DNS traffic to the 10.0.0.4, and 10.0.0.4 is the private IP address used by the inbound subnet. And behind this subnet we have workloads, like either that could be virtual machines or virtual machine scale set. You don't see it, but that is what is running this server and is managed and hosted by Azure, because you have workloads there, then those workloads could resolve the domain names or any private DNS zone that is linked to the hub network, including the contoso.azure. With that way, the virtual machine will be able to resolve the domain name contoso.azure by using the rule set link in order to get that forwarding rule set and then issue a DNS query to that private IP address. So note that here it's not the VM who will try to reach this IP address. For that, we say here that the peering is not required. But however, that operation will be done by the DNS Private Resolver, and it will get back the result to the VM through the rule set link. Excited to see this in action? Follow me in the next video to go through a demonstration where we go to deploy those resources within Azure and test how it works. In this video demonstration, you will learn how to use Azure DNS Private Resolver to unlock the scenario where we can resolve domain names from Azure to Azure. So for that, we would define a hub virtual network and a spoke, and within the spoke, we would have a virtual machine that will be able to resolve a domain name that is hosted as a private DNS zone linked to the hub network. To achieve that DNS name resolution, we'll be relying on Azure DNS Private Resolver and forwarding rule set configuration that will be using an inbound subnet, outbound subnet, and rule set link to the spoke virtual network. Along this lab, we'll follow those 15 steps to implement this architecture. So let's start first by creating a hub virtual network with no subnet and a private DNS zone called corp.azure with an A record called address1. That will be linked to the hub virtual network. To do that, I'll switch to the Azure portal and I'll go to look for virtual networks or VNet, and from here I'll go to create a new virtual network. So I'll specify the virtual network resource group. I'll go to create a new one. Let's call it RG Hub. Then click OK. And next I'll provide a name for the virtual network. Let's call it VNet-Hub, for example. I'll continue with the region West Europe, but you can choose whatever you want. And then next, I'll go to the IP addresses, where here, by default, you see that it will create a new subnet called default. I don't want this for the moment, so I'll go to delete it, and then I'll go to review and create. Then start the creation process, which will take just a few seconds. And meanwhile, we'll go to perform the step number 2, which is creating the private DNS zone. So I'll search for DNS private zone. And then I'll go to create a new one. So from here, I specify the same resource group, which is RG Hub. Then give a name for that zone. Let's call it corp.azure, for example, and go to review and create. Once it's created, I'll go navigate to that resource and I'll go to add a new record. Let's call it address1, for example, and let's give it an IP address like 1.2.3.4, just a sample IP address for this demonstration, and click OK to add it. And then next we'll go to link or add a link for the hub virtual network for this private DNS zone. For that, I'll go to click add, and let's say this is the link for the hub VNet. And then from here, I specify my VNet hub from within the RG Hub resource group, and I'll click OK. Make sure the link is created, and then next we'll perform the steps 3 and 5, where we'll go to create a Linux virtual machine from within the hub network. We call it VM Linux Hub, and we'll try to resolve the domain name address1.corp.azure from that VM. So for that, I'll go back to the Azure portal and go to look for virtual machines or VMs, and from here I'll create a new one. I specify the resource group for that virtual machine should be RG Hub. Then we give it a name, and then we choose here a more recent image, like for example the image 22.04, the LTS version using generation 2. Choose the size for your VM, and you can also enable the spot instance to reduce the cost of this VM. Then next here, actually we don't need the public inbound port to connect to this VM. And then next we'll go to the disk configuration, where we go to choose a cheaper disk like the standard HDD. And next within the networking section, we'll go to provide a subnet and a VNet for this VM. It doesn't have yet a subnet, so I'll go to create a new one. I'll call it here the subnet for VM, subnet-VM, hit save. And now I can go back to the creation of the virtual machine, and it will take that new subnet for me. Here I don't need also a public IP address, so I'll just select none, and none for the NSG rules. And then next I'll go to review and create. Start the creation process, accept to download the private keys. Once the resources are created, now we can go to the resource group for the hub, and from here we can see our virtual machine. Now from this virtual machine, we'll go to try to resolve the domain name for corp.azure. For that, I'll go to rely on the run command feature within the virtual network, the virtual machine, and run shell script. And here I go to run the DNS lookup for the address one.corp.azure, which is a record that I've created earlier. And note here, this virtual machine will be able to resolve that domain name because that custom DNS zone is linked to the virtual network where this virtual machine is running. And here we can see that private IP address coming from that DNS zone. Now let's simulate the use case where we have a spoke virtual network in which we have a virtual machine. That virtual machine will not be able to resolve corp.azure because it's not linked to the subnet or to the spoke virtual network. Let's try this. So from within the Azure portal, I'll go back to create a new virtual network, click create, and then I'll put it in its own resource group for the spoke, call it rg-spoke, and then give a name for the VNet. Let's call it just VNet spoke. And then within the next section, I'll create the default subnet within that spoke, and I'll go to review and create. Start the creation process. And once the VNet is ready, now we can go to provision a virtual machine within that VNet. For that, I'll switch to VMs, and I'll go to create a new virtual machine within the spoke network. I'll put this within the RG spoke resource group. I'll give a name for the virtual machine, and then I'll specify the image name, which is 22 LTS, for example, and then you can choose a size and enable the spot to reduce the cost of this lab, and then set none for the inbound. And next for the disk, choose the standard HDD to reduce the cost. And next for the networking section, you specify here the virtual network on which was the VM, which should be here the spoke. And next you select the default subnet. I don't want to continue with NSG, so I'll keep it to none, and then I go to review and create. Then when it's created, we can go to the resource group of the scope. And from here, I can access that virtual machine. I'll go again to look for the run command, and I'll go to use it with the run shell script in order to try to resolve with DNS lookup the address one.corp.azure. And as expected, this resolution will fail because that DNS zone is not linked to the spoke network, but it's linked to the hub virtual network. What we'll do next here is that we'll go to try to use Azure DNS Private Resolver, configure the inbound subnet, outbound subnet, and the forwarding rule set for the virtual machine from this spoke to be able to resolve the corp.azure domain name. So to do that, we'll go to create a new private resolver and inbound endpoint, outbound endpoint, and a rule set. I'll keep this window here open because I will perform that DNS lookup later after configuring the DNS Private Resolver, and I'll move here to this tab where we go here to create a private DNS resolver. So I look for DNS Private Resolver. It's this one here. I'll go to create a new one. So to create it, we should go through these templates right here. So first of all, we need to specify an Azure subscription and a resource group. Typically, it will live within the hub network. And then we give it a name. Let's choose DNS Private Resolver. And then we choose an Azure region. Then we select a virtual network. In this case, I'll be using the VNet hub from the RG resource groups. And then next note here, we can specify the inbound endpoints, the outbound endpoints, and the rule sets. We will not do that here, but we'll do it later after creating the resource. So let's create the resource right now by clicking the create button. And within just a few seconds, the private resolver was created successfully. Now I can go to the resource group where I have that private resolver, hit refresh, and I can see it right here. So I'll navigate to that resource. And within here, we can see the way to configure the inbound endpoints and the outbound endpoints. Let's start first with the inbound endpoints. So I'll click on adding a new endpoint, give it a name like inbound endpoint, and then we select a new subnet from within the VNet hub. For now, I have only the subnet for VMs, but I want to create a new subnet for the DNS resolver inbound. Let's call it subnet for inbound. And we are okay to use the CIDR range /28. Even /24 is what is recommended for production. Click create. And then next, this will create also a private IP address that could be either assigned dynamically or statically. Statically, it means that you can specify a specific IP address within this CIDR range. For simplicity, I'll continue with the dynamic IP address, and then next I'll go to save this configuration. And now Azure will go to provision an inbound endpoint for me. And now it seems that it did create that inbound endpoint, and note this IP address right here, this private IP within the CIDR range of the subnet. We'll use this later for the rule set or for the forwarding DNS rules. Now let's move to the next section where we'll go to create an outbound endpoint. So the same way as we have created the inbound endpoint, we'll give it a name like outbound endpoint, and then we specify a new subnet for it. So let's choose here, for example, subnet with name subnet outbound, and give it CIDR range /28. Then next, click on save. And now Azure is creating that resource for me, and note here, it will not have for now an associated rule set because we don't have a rule set yet. So the next step here is to create a new rule set and then create a rule for the domain name corp.azure and link that rule set to the spoke virtual network, so then later we can resolve that domain name from the Linux virtual machine from within the spoke network. To do that, I'll go to search for rule set, and here I find DNS forwarding rule sets. I'll go to create a new one, and for the rule set we specify the subscription, the name of the resource group, and then we specify a name for the rule set. Let's say this is the rule set number 1, and then we configure the endpoints. So we should provide a DNS or private resolver, so we choose the one we have created earlier. Then we select the outbound endpoint. Then next here we can configure the rules and the virtual network links, but I'll do this after creating the rule set. So I'll click review and create, start the creation of the rule set, and within a few seconds we should see a new rule set created within the resource group for the hub. That rule set is this one here. As you see, it's already bound to the outbound endpoints, and now from within this rule set we'll go to configure the rules. So we'll create our first rule that will help to resolve the private DNS zones domain names. So let's give a name for the first rule. Let's call it corp-azure, for example, and then the domain name that should be resolved here is corp.azure. And note here I should add the dot at the end of this domain name. Remember, corp.azure, that was the name of the private DNS zone that we have created. Then next we should here say that this rule will be enabled. You can disable it whenever you want. And then next we specify here the destination. So when a workload or a virtual machine will try to resolve a domain name from corp.azure, it should be, or that DNS query will be forwarded to a destination IP address, which should be the same private IP address that is specified within the inbound endpoints, which is in my case 10.0.1. So I specify that, and note here it is already using the port 53. I'm okay with that. And then I'll go to add this rule. Once that rule is added and configured, now I'll move to virtual network links, and here I'll go to link this rule set to the spoke network. For that I should specify the name of the resource group where I have my spoke virtual network. My VNet is within the RG resource group, and here I provide a name for this link like VNet spoke link, for example, and I click add. That link is now added, and that means that here we have configured this scenario for Azure to Azure, where we have a virtual network or a virtual machine within the spoke virtual network, and we have configured the forwarding rule set and the rule set link to that network. And now this VM should be able to resolve the domain name from corp.azure. Let's test that scenario. For that, I'll go back to where I have left this VM Linux spoke that is running NSLookup, and remember earlier this DNS resolution didn't work, but now with DNS Private Resolver, if we run that command again, this time it works, and it works fine, and it gives me here the private IP address served by address1.corp.azure, which is the one we have defined here earlier, which is 1234. So this was how the Azure DNS Private Resolver can unlock the scenario of resolving DNS names from Azure to Azure.